So we're going to discuss today reciprocal identities for trigonometric functions. So when we talk about a reciprocal, we're talking about a ratio. We're going to talk about the opposite. My numerator is going to become my denominator. My denominator is going to become my numerator. So since sine, cosine, and tangent are all ratios, they all have a reciprocal ratio that we're going to identify and give a name today. So if the sine ratio is opposite over hypotenuse, there's a reciprocal ratio, hypotenuse over opposite. Cosine is adjacent over hypotenuse, there's going to be a reciprocal ratio, hypotenuse over adjacent. Tangent is opposite over adjacent, and we will have a final reciprocal relationship of adjacent over opposite. So this is really going to create three new trigonometric functions that we will study. The first one is going to be cosecant. Cosecant is hypotenuse over opposite, so cosecant is really the reciprocal of our sine function. So when we think about sine, we know sine is hypotenuse over opposite. The reciprocal now is going to be called cosecant. You can see above here, that's how we spell it, but we abbreviate it CSC. So if we go back to the unit circle, we know that we talked about sine being y in the point, because it's the, again, relationship y over 1, opposite over hypotenuse. So cosecant can be referred to as 1 over y, also if we're thinking about the unit circle. Now secant. Secant is another reciprocal relationship. So secant is hypotenuse over adjacent. Now the adjacent over hypotenuse came from the cosine ratio, so secant is going to be 1 over cosine. Again, here's the full spelling of the function, S-E-C-A-N-T for secant, however, we're going to abbreviate it S-E-C. On the unit circle, when we talked about cosine, cosine was my adjacent over my hypotenuse, x over 1, or my x value in the point. So secant is going to be 1 over x, if we're referring to the unit circle. And the last of these three reciprocal functions is cotangent. Now cotangent is kind of a nice one because cotangent does share the word tangent with its reciprocal relationship. So instead of tangent being opposite over adjacent, cotangent is adjacent over opposite. Cotangent is 1 over tangent, the reciprocal. And again, tangent, we know when we talk about the unit circle, tangent is not one of the values in the point. However, we know that tangent is opposite over adjacent, or y over x. So cotangent is going to be x over y. And what's unique about this, we know y is sine and x is cosine. And we said that tangent was sine over cosine. So now we have another relationship being formed here, that cotangent is really cosine over sine. Okay, so the reciprocal identities, if we just have them all out in front of us, just kind of think about these. So sine and cosecant go together. Cosine and secant go together. It would be nice if the s functions went together and the c functions went together, but unfortunately it is opposite. So when we think of this new function cosecant, cosecant is the reciprocal to sine, s goes with c, cosine goes with secant, that's another c and s going together, but the tangents do stay together in their relationship of reciprocals. We talked about tangent being sine over cosine. So now we have this ratio identity that cotangent is cosine over sine, again, also coming from the reciprocal nature with tangent. Okay, so let's try some examples using these new reciprocal functions. So for question 1, we're told that given that the cosine of theta is 12 over 13, so here's my triangle, I'm going to label what I know. Cosine is adjacent over hypotenuse, so my adjacent side is told to me as 12, the hypotenuse I know is 13. We're asked to find the value of the 5 remaining trig functions. That's right, now we have 6 total functions. So I'm going to think about cosine. I labeled my triangle. but I'm missing this opposite side. So let's, again, take a minute to talk about the Pythagorean theorem. So we have 12 squared plus the missing side squared equals 13 squared. So performing the Pythagorean theorem here to find the missing side, we get the side length for our opposite side to be 5. We also, if you remembered this Pythagorean triple, 5, 12, 13, you could have just labeled that side with 5. So now we can use SOHCAHTOA to help us with sine and tangent. Sine is opposite over hypotenuse. Now I know the opposite side. 5 over 13 would be sine. Tangent would be 5 over 12. I think it's helpful when you're finding the reciprocal functions to think about what their partner was. So cosecant and sine are reciprocals. So when I go to find cosecant, I'm going to look at the sine ratio and flip it. All right, secant and cosine are reciprocals. So cosine is what we were given originally, so I'm going to take a look at that 12 over 13 ratio and find the reciprocal of it, 13 over 12, and that's going to be my secant of theta. And the last reciprocal relationship is tangent to cotangent. So the tangent of theta was 5 over 12, so the cotangent of theta would be 12 over 5, it's reciprocal. Okay, so as we move along in the notes, I am going to skip a couple questions. The ones that I am skipping, I would like you to go back at the end and try, and I will put the answers up at the end of the video. So now I'm going to skip number 2 and move on to number 3. So number 3 tells us if the sine of this angle theta is 4 over 6, so we're given this information, let's label our triangle accordingly. So opposite over hypotenuse is 4 over 6. Find the secant. Okay, well, secant theta is a new reciprocal function, so I need to think about what it is the reciprocal of. Secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. So I'm missing that adjacent side, so I need to use the Pythagorean theorem. Okay, so applying the Pythagorean theorem here, we find the missing adjacent side to be 2 radical 5. So the secant of theta is hypotenuse over adjacent, so it's 6 over 2 rad 5. I'm going to simplify this first. If you want to go in this order, you can. 2 divides into 6 3 times. I get 3 over radical 5, and then I need to rationalize that. Rad 5 over rad 5 will give me a simplified secant ratio of 3 radical 5 over 5. Okay, so we're taking a look at our 30, 45, 60 chart, and this is the chart you are responsible for memorizing, knowing. You should be practicing every day, writing this down in your notes at least once, each night when you're working on your homework. This chart is important to know. However, we are not going to ask you to memorize the chart for the reciprocal functions. However, we're just going to take a minute to go through them. But when you actually need to apply these values, you're going to refer back to the reciprocal function. So if I'm thinking about the cosecant of 30, I'm going to think about the sine of 30 being 1/2, and I'm going to take the reciprocal of 1/2, which would be 2. And I would do that in the problem. But we're going to take a minute right now to fill in this chart. So each of these, I'm just going to first just find the reciprocals by simply flipping the ratios. And then we're going to point out the ones that we need to rationalize. Okay, so any of these that have radicals in the denominator, I would like you to take a minute to rationalize them, and then I will place the answer up on the slides. Okay, so if we rationalize all of them except for the 3 that did not need rationalizing, this is what our chart would look like with the correct simplified values. Now we're going to answer a couple questions that need these values, but again, we're not going to keep referring back to this chart because again, I'm not asking you to memorize a brand new chart. Let's take a look at this question. We're being asked to find the exact value for the following trig functions in simplest form. So I'm going to break this up into two pieces. Let's first just look at the cosecant of 60. So I want to remember that the cosecant function is the reciprocal of the sine function. So the sine of 60 is something you are responsible to memorize. The sine of 60 is radical 3 over 2. So that means the cosecant of 60 is 2 over radical 3, which we would then rationalize to get 2 radical 3 over 3. So far I have the first part of this sum. I'm going to add it to 2 times the cotangent of 45. Well, now I need to figure out what the cotangent of 45 is. Cotangent is the reciprocal of tangent. So let's think about what the tangent of 45 is. Well, this one's kind of nice because the tangent of 45 is 1, and this is the value you're responsible to know. So if you take the reciprocal of 1, you end up with 1. So I end up with 2 radical 3 over 3 plus 2. Now I would like to write this as one simplified fraction. So I need to come up with a common denominator. I want to add these two together with a denominator of 3. So if I want this number to have a denominator of 3, I need to multiply the top and bottom of this number by 3. I end up with 2 rad 3 over 3 plus 6 over 3, which equals 2 rad 3 plus 6 all over 3. Okay, the next thing I want to take a look at are the signs of our reciprocal functions. So I want everyone to think about for a second, what if I gave you the fraction 2/3? Okay, think about the reciprocal of 2/3. The reciprocal of 2/3 would be 3 over 2, right? We flip the numerator, we flip the denominator. What if I gave you the fraction -4 over 5 and asked you to find that reciprocal? Think about that for a minute. The reciprocal would be 5 over -4, or -5 over 4, right? When you take the reciprocal of a number, it keeps the same sign. So with that being said, our functions, these new 3 functions, are going to follow the sign of their reciprocal function. So we already know all students take calculus helps us know that in quadrant 1, all of my functions are positive. So that means that all of their reciprocal functions are positive. In quadrant 2, the S tells me that only sine is positive in quadrant 2. Well, now that sine has a reciprocal, cosecant is also positive in quadrant 2. Everything else is negative. The T stands for tangent. So we had been told, we know that only tangent is positive in quadrant 3. But tangent now is known to have a reciprocal function, cotangent. So tangent and cotangent are positive in quadrant 3, and everything else is negative. And in quadrant 4, the C stood for cosine, so cosine was positive in quadrant 4. Cosine now has a reciprocal function of secant, so secant will also follow the sign of cosine, and all of my other functions will be negative. So we're not going to learn another acronym. The biggest thing here that you need to remember is what reciprocal function goes with what original function. And then you just remember, all students take calculus to help you remember which signs are positive and negative. So let's do one last question together that kind of brings it all into one question. We're going to find the exact value of the cosecant of 300. Now, when you see something asking you for the exact value, this could maybe be asking you to find a trig function of 30, 45, or 60, because those are angles that we expect you to know the exact value of by memorizing that chart. So if you see an angle that's larger than one of these, we use that method of Q-suffer. So again, Q stands for what quadrant are we in, S stands for the positive or negative sign of the function, S stands for the function you're dealing with, and R stands for the reference angle. So let's start by drawing this angle of 300. So 300 degrees is going to be an angle in quadrant 4. Okay. Okay, I'm going to draw that terminal side, and I'm going to highlight my x-axis there so that I remember eventually I'm going to need to think about this referencing. I'm also going to add my all students take calculus. So to find my reference angle, 360 minus 300, just to complete my diagram here, there is a 60-degree reference angle in quadrant 4. Okay, now we are dealing with a reciprocal function. We're dealing with cosecant. So in quadrant 4, I'm thinking about sine, because sine and cosecant are reciprocal functions, and they follow the same signs. So if I'm in quadrant 4, the sine function would be negative, so is the cosecant function. The function isn't sine, but we're using sine as our reference. We have a reference angle of 60 degrees, and now we know that the cosecant of 300 is really equal to the negative cosecant of 60. But we're not just being asked to write this as a function of something positive and acute, we're being asked to find the exact value. So this is where we bring sine back again. The sine of 60 is radical 3 over 2. So the negative cosecant of 60 is negative 2 over radical 3. It's negative because we're in quadrant 4, and it's 2 over radical 3 because it's the reciprocal of sine. So if I take my last step, which would be to rationalize this, I get negative 2 radical 3 over 3 as the reciprocal of the sine of 300. Now I just want to take a minute to show you how to type this into your calculator. So we don't have additional buttons in our calculator that say secant, cosecant, and cotangent. However, we have the original 3, and we just talked about the fact that these 3 functions come from the reciprocals of the original 3. So if I want to type in the cosecant of 300, I'm going to type in 1 over the sine of 300. Okay, so if I type in 1 divided by the sine, right now my calculator knows I'm referring to cosecant, which is the reciprocal of sine. Type in the 300. Okay, hit enter. And now we want to type in what we got to match it up. So we got negative 2. So let's open up a fraction. Negative 2 radical 3 over 3. And we show that we got the same answer that we started. Okay, so now what I would like you guys to do is go back to your notes, go back to question 2, go back to question 4. We did this one, so please try these remaining 3 questions, and we did this last exact value. Please try those last 3. I'd like you to pause the video, work on these questions. I'm just going to put the answers up here so you can check. I'm not going to do the work. We can go over questions that you have on the remaining parts of this packet in class. Here are the answers to question 2. Here's the answer to number 4.